Okay, so you should have seen the op-amp fix the dog, or at least hide the dog, which is to say the crossover distortion of the push-pull amplifier. Quiz 4 asked you to look at another type of undoing a dog, which is to say in the non-inverting configuration, the op-amp has to undo whatever we put in the feedback loop. So if we put a divider in the feedback loop, we get gain. So here's quiz 4. Usual design rules. So we've got an op-amp in a non-inverting configuration, and in the feedback we have something that does a cube, does V cubed. So our output voltage is cubed and applied to the minus input. And it asks you to figure out V out as a function of Vn. Well, we'll just use the op-amp rules. Is there negative feedback? Well, if V out goes up, V minus goes up. If V out goes down, V minus goes down. So we do have negative feedback. That means that V plus equals V minus. V plus is equal to V in. V minus is equal to V out cubed, because we take V out and cube it. We can set those together, and we know this, that V in equals V out cubed. And if we want V out as a function of V in, V out is equal to the cubed root of V in. So this circuit gives you the cube root of the input circuit. And that makes sense. If we put in 1 volt here, we get 1 volt here. We get 1 volt here. That's fine. If we get 2 volts here, well, let's see. We want 2 volts here. But whatever out of here has to be cubed to give 2 volts, so we better get the cubed root of 2, so that when we multiply it by itself 3 times, we end up with 2 volts. So here's a circuit that gives us the cubed root of Vn. And all it's doing is undoing whatever's in the feedback loop. It's undoing the dog. So let's see what our question are. What does this have with undoing the dog? Well, undoing the dog is just our argument that in the non-inverting the op-amp undoes whatever the feedback does. And we can use this to get logarithmic circuits, exponential circuits. Anytime we can create a function, the op-amp allows us to create the inverse. And that's kind of neat. Why did I choose V cubed for the feedback rather than V squared? Well, I did that because there's a problem if this were V squared. If this is V squared, V out is always going to be positive no matter what V out is. So if I put in a negative voltage, there's no way the output of a squarer can be negative. This circuit doesn't work for negative voltage if it's a squaring circuit. Now, if I had used V squared here, as long as V in was positive, the output would be the square root of V in. But we'd be limited to positive input voltages, and I didn't want to add that complication. But certainly if you're willing to only use positive input voltages, you could build something that calculates square roots, at least voltage square roots, using this circuit. So I used the cube because the cube maintains polarity. All right.